Okay, hello to people joining this live stream. We are talking about our initiative in multi-computation, and looks like Nick has some things to demonstrate here.
So just basically a few more new examples, because I refactored this object almost from scratch.
Okay, so let's understand what this object is. So multi, what is it doing here?
So this is like a holder for a bunch of rules and options right now. You give it an expression, and you can give it an expression and a list of explicit rules. That's
okay.
one of the things that it can do.
And on those, okay, I'm very confused here. So this is an unevaluated version of this thing. Does it just run here? Yeah, because you've got a thing there.
Yeah.
Okay, so what's it doing now? Is it trying to run to a fixed point? Oh, come on. Let's take a look here. How do I see what it is? Wait a minute, page unavailable. It's trying to go to the generic function repository. Is it there or is it not there?
No, it's not there. Can you try this one? You can just take the code in the Multicomputation folder.
What happened here? Failed to find resource. So that's a cloud object.
Can you just say cloud get or something? Or maybe it's private.
No, I'm pulling up that page as a web page, but this doesn't look like it's the right kind of page. That's not the resource object.
It does say function resource.
It's a resource object. It's a resource function without documentation. It's just a raw function.
Okay.
The same way that we did in the block.
Oh, on that page, try pressing the copy button to copy the link. Like press on the thing that says multi. Doesn't that copy it? I wonder what it copies. Basically the same thing. Maybe Nick, if you could run like set permissions on it or something, although it does look like it's public.
Oh, it's a perfectly published function. Maybe it's a new prototype thing. I don't know. You can just evaluate the code.
Hold on. Okay, wait a minute. Let me not confuse everything by doing that. Okay, let me not do that. Here, let me just take this and run it in an existing build. Okay, we may just have wasted our time here because that was probably a pure. Okay, let me take this. That's probably a 13.1 bug. Probably should get reported, but
well, your build was from like 2 weeks ago also.
The 13.1 build? Really?
It said March 29th.
Oh, come on. This is failing too. It says page unavailable. When I click that, it says page unavailable. So that seems like
that's the wrong page. So why don't you get the correct address from the Zoom chat and try doing it in the correct build?
Okay, I think there's a permissions problem. Or
can you just not use quad object? Then just a string. Can you give it a string? Because I'm just publishing it. It's publishing without permission as a public by default. So I guess. Okay.
Can you
can
say options of that, comma permissions, or can only Nick do that?
I don't think I can find that out.
Well, we can just evaluate the code itself. It's in the
Okay.
multi notebook, as we
Okay.
did previous time.
Where is that notebook?
It's in the multicomputation.
Okay.
directory.
Multi.nb.
Yep.
Okay, great.
Hopefully those resource functions gonna work. But it depends on. Just evaluate all the initialization cells. Okay, those are fetching fine.
Okay. So now, define resource function. Is that what we want? Well, okay, is this, I don't know, did that do the right thing? Or now what should I do over here?
I'll just replace with multi.
Uh,
Just don't use a box. Fine.
okay, what did that just do?
Right now, just tried my multi-repost function on this object with those rules. And all the matches that it found just stores them. And then you can just query it with a bunch of properties. Like you can evaluate it and it will give you like try multi open bracket evaluate string. No, like
You
this
save it in
like
a variable.
as a property. If you save it to a variable, you have to wrap it and evaluate, or it will do it like this.
It ate the set.
Yeah, it eats the set because it doesn't hold arguments.
What? Okay, so I do this and then I say multi equals %.
I'm not sure even that will work. In fact, I don't think that will work. No, it won't. Even that won't work. Oh no, okay. Oh no, it's because.
No, you can look at this object, but I don't think it works.
I'm totally confused.
Wait,
We'll have to
multi
treat
has
it
up
carefully.
values. Multi has up values so that any function you apply to it, it eats. So you need to, so including set. So you need to use unevaluated around it in order to set it to a variable.
Clearly, this isn't the right way to do things, and that didn't work.
No, because you didn't put the
Well,
set.
you assign it to something.
Right. So really, there should be some outer. Multi is the inner thing, and there should be some outer wrapper, which effectively is like unevaluated. I mean, it's only real properties that it's told first. But yeah.
I'm completely confused about why it's doing this. I don't understand why it did this.
Why it worked.
Yeah, I understand that, but why
does
it eat everything?
Well, because it's intended as this, not just a holder for rules, but a bunch of other things. It's like you can use it in any kind of expression, and it just eats it up. And
if you say 2 plus multi of 3, 5, right? Like it has to be able to eat the thing outside of it, right? That's its whole point for existing.
Right.
But I agree.
How do I see the result? How do I see the result here?
Evaluate, or just try evaluate, or least evaluate. Like this, for example.
There you go. That's pretty cool.
Okay. Okay, so, but the concept here is, this is like something like listability or sequence expansion. This is a thing that happens at a low level in any expression. And right now it's a little bit unruly because it, unlike sequence, there is a sequence hold which prevents sequence from just rampaging all over everything. This thing can just escape and go over everything right now. Is that fair?
Yeah, like set has a sequence hold, and the rules have a sequence hold, that because it's the common case.
Yes.
But in this case, it's just
It doesn't have that.
overrides it.
Okay.
Yep.
All right.
Just,
okay.
I mean, I think that probably, I mean, the simplest thing would just be to have some symbol, I don't know what to call it, multi-environment or multi, enclosure or whatever you want to call it. And, in the up value for multi, it just has an exception for that one symbol where it won't eat that.
Or you just have a constructor here that says, I mean, I'm still a little unclear what the semantics of this is. This is a thing that is that expression, but there's an outer, in this case of 2 plus multi, it's the outer function that is being treated, where you're kind of.
Those are two different constructors on the screen right now.
Well, they both say multi.
Right. I mean, well,
No, they're the same. You still can add 2 to this multi variable that you have. It will add a placeholder to that combinator then.
They're different usages.
Okay, but okay, fine. But this one is also one of these, instant explosion multis here.
Yes, because the whole point is it's just, it doesn't matter how you create it. If you have this, as you call it, instant explosion multi, you can still say 2 plus that, and it should eat the 2 and create a bigger multi.
Yeah, okay, fine. But then what is this doing in this multi?
It just, it's another, it just provides a list of rules, explicit rules that it's going to use.
As opposed to just looking at down values effectively.
Yeah.
Which it could also do or could not also.
Yeah, it could also do. If those S and Ks were just defined in the usual way, we're just defining down values, it's going to just extract them properly.
And only go one level? Only go one level when it extracts them? Because, I mean, this thing, if I give a non-terminating combinator, as it starts to extract, is it just going to blow up?
No, that's why you only extract it once. It just looks at where it can be applied, records it, then you just ask how much times you want to extract it or evaluate it. Okay. So it's not going to explode. It's just going to take some time.
Okay, because the thing it makes is just an unevaluated thing, and you have to explicitly tell it to go some number of levels of evaluation.
Yeah.
Yes.
And in case if you had an actual definitions, there are hold versions of those properties when it stops evaluation.
Okay, I get it.
Just in case.
So list evaluate hold would be this thing where these things are frozen by hold.
Yeah. It's hold list evaluate currently. So maybe hold.
Fine. No, that sounds right. But okay. But now, and the foliation that you're using in this kind of evaluate thing is some kind of generational evolution type thing. Is that right? How is it picking which ones? When you say, go ahead.
Evaluate just evaluates like all at once, all space like separated rules that can replace at once, they're going to fire at once. But I have an option evaluate once that actually applies a single replacement. So it will produce a list of all possible expressions when you just apply it once.
But the space but there may be multiple choices of space-like separated updates.
Yeah.
So what is it? Which one does it do?
Well, evaluate just doing the default.
Okay, the default thing is the evaluator. Okay, fine. All right. Okay, so that will be affected by the traversal order options and things when that is all hooked up.
Yeah. Right now it's just whatever replace part, I guess, is gonna do. If you just feed it all the position in order they were found.
Well, wait a minute. That's not right because there can be overlapping ones.
Well, you can replace part can have an overlapping one, and whatever the first one is gonna take effect over the last one, I think.
Okay. Well, I don't quite understand that, but anyway, that's okay. So let's take a look at this. So this is now saying in here, could we look at a slightly more, I mean, I don't know what this combinator does. Let me find one where I do know what it does. just want to understand what this is doing here. Let's pull up a friendly combinator. All right, let's pick this combinator here. Okay, that one there. And now what I want to do oh my gosh, multi-clicking is not such a panacea in a case like this. Okay, so now what I want to do is multi of graph, comma 10. Okay.
Is the fixed point just repeating itself then?
Okay, so you might want a right, a fixed point graph notion. Does anybody know
Sure.
where are we putting this? Oh gosh, I don't know where these are going, but anyway, okay. So, okay, well, that's encouraging. That looks the same. So for example, if we were to take just to give a sense of the kinds of things we might need, right? Actually, I'm just curious how well this one does. I mean, is this decently efficient or not? Yours?
I'm not sure. I haven't spent much time optimizing it.
Let's see, but I'm going to go 20 steps or something. Humph. Okay, so there's probably some. Okay. Well, it's plausible. Different looking than this one, but anyway, who's to know? All right, I think I get it. So in this case here, okay, lovely. All right, so let me understand this input here. Okay, so this was a multi where these rules, these are sort of temporary assignments that are being used here. What does the all mean?
It's a level. So you can those rules can apply everywhere.
Right, those rules are like the second argument to replace, and then the all is the third argument to replace, basically.
Yeah.
Okay, and this means replacing the heads. What does method arrow substitution mean?
No, that's our three methods of strategy substitutions. Co-substitution or by substitution also should work. Not in the case of combinators, I think, but yeah.
But for those to work, this would have to be a pattern object, correct?
Yeah.
For those to be non-trivial, that's a pattern object. So I would like to say that I'm very keen for us to have a bunch of other helper functions that deal with pattern manipulation, for which those, you know, co-substitution, bi-substitution, and so on, those are things that should be part of the family of functions that deal with pattern manipulation, in addition to being here. That makes sense.
I agree.
And in the end, I don't think this should be method arrow substitution. This should be just replace or something here. And then you should also be able to have, you know, co-replace or whatever the right term is as an alternative there. Does that make sense?
Well, yeah, maybe. Right now, it's just feeding options.
So, sorry, say that again. I mean,
were you saying that you want a named argument rather than an option?
No, I'm saying that I think the correct version of this is that should be, okay, that in a different world, this would be multi of that. And then this whole thing just says replace hash, comma, blah, ampersand. That essentially what it's saying is this is a multi where at every step, or maybe this isn't the right semantics, I don't know, where at every step, this is the operation that you're doing.
So now it's a function. So you could just rewrite it as a rule. It's just x goes to replace x.
Sure. Right, but what I'm saying is that I'm trying to understand what this multi thing actually does. And what you're saying is that this is something that runs in front of the evaluator. Is that correct? On an expression inside a multi.
What do you mean runs in front of it?
Well, I mean, so let's say I'd said multi of 2 plus 2. 2 plus 3, whatever. Okay?
Okay.
I don't know how I do this. I mean, it's pretty hard to use, but anyway, let's just say this. Yeah, I thought that's what it would do.
Or you can wrap your 2 plus 3 with another evaluated. Or with hold.
No, I understand, but what I'm saying is that if you think about what this multi is doing, it is at every step, it's multi-running the evaluator, or its version of the evaluator, if I'm understanding correctly. In other words, by saying it's multi-running the evaluator, what I mean is that okay, if I have 2 plus 3, 4 plus 5 here. Okay, now I'm totally confused. I'm just irreducibly confused.
Well, if you feed it a list, it's a little bit different constructor. You can
that's what
right now we can.
This. I mean, okay. How do I get this out? Evaluate list. Okay. Sorry, what were you going to say?
You can just supply like a second argument, empty list, because like empty lists of rules, and then it's going to be that list going to be treated as an expression instead.
Okay, out of curiosity, I mean, do these constructors work in a way where like you can do the list constructor, but quote unquote dynamically? Like, could you have something like here's a weird one you could write, like multi of select of some list, and then maybe the test for the select is in a multi as well, if you get what I mean. So the outer multi can't tell until it evaluates the select that its argument is going to be a list.
Well, it's going to treat it as an expression, but it can be a list of some unevaluated expressions.
Right. Okay. I'm just wondering, like, does it need to know about the list at multi-construction time and needs to know its length and its arguments, or can it sort of do that in some weird dynamic magic way? I guess probably not.
Should. Well, for this specific semantics, when you treat a list as just a list of alternatives and you have this special number of values that it can take, then it had to be a list from on the construction.
So if you even say something like, here's an easy thing to write, just say L equals, 5,6, and then say multi of L. What's that going to do? Is that going to
say it again? Multi of what?
Multi of, or I guess I kind of know what this has to do. Like if you say L equals 5,6 and then multi of L, that's going to do something. Multi is hold all is the point basically, and it's seeing it's gonna. No. L equals 5,6 and then multi of L.
Oh.
Multi is not hold all.
Oh, so this is going to do the same thing as just the list 5,6.
Yeah.
Okay,
yeah.
Listen. There's some problems with the way this constructor works, but let's not get hung up on that. Okay, I want to understand the bigger picture here. So what does multi, okay. What multi fundamentally does is it's going to build up some data structure here that represents sort of this process of evaluation. This is a seed for the evaluation that is sort of a trivial case of a process of evaluation, which is merely the initial state of two disconnected or n disconnected expressions. Is that right?
Yeah, you can think of it like this, I guess.
Okay, but then the actual process of evaluation done by the multi, in my way of presenting it here, is either the repeated, I mean, because the default, okay, let me see if I understand. The default is that we have an expression, and although we don't really quite, this isn't quite the right name for it, but essentially we're just running the evaluator at every step, the default evaluator at every step to determine the result of any sort of branch of the multi. Is that right?
Well, no. It's not running evaluator like by default. It's extracting the down values. That's the default behavior if you just feed it an expression. And those down values treat it as rules. So it's not really running evaluator in the usual.
Okay, so it's running a fake version of the evaluator. It's running a shadow evaluator based on down values and sub values and own values.
Yeah, right. All of them.
Okay.
But did it work also for like down code? Like if you do, you know,
No.
if you do,
No, it will not
okay.
do that. That's the whole point.
I have a special option like what pattern just run as a down code. So like eval. In this case, it just runs an actual evaluator. If you find this pattern, just evaluate it.
Okay.
Okay, but you have to tell it what things to like.
Yeah.
So basically, if you say just multi of 2 + 2, it's going to be a little bit confused. Like it's not going to realize that evaluates to 4.
Yeah, it doesn't know because there's no down value. But if you provide a pattern, evaluate plus, then it will just gonna evaluate it into 4.
I see.
Okay.
Right. Yes.
Okay, but then the second thing here, at least in this design like this, would be an alternative evaluator. So this, we could call this, you know, the Nick evaluate or something. Okay, or rules evaluate. Let's call it that. Rules evaluate is a version of the evaluator that just uses, I mean, in principle, we could have a function, rules evaluate, that just does this, that switches up. That might be an interesting function in its own right. Basically switches off.
It's already a function.
What is
like
it?
It's my multi-evaluate function. It's not, but this object uses it as a workhorse.
Okay, but wait, why is it multi-evaluate? Well, as opposed to rules of, I mean, if I'm understanding correctly, there's a version of this in which one could have defined, you know, if it's rules evaluate of f of g of x, f of g of 1 or something. No, actually, let me be more precise here. Let's say it's f of 2 + 2 rules evaluate f of 2 + 2, where rules evaluate doesn't evaluate its argument, but if there's a definition for f, it will run it, but it doesn't run the down code of plus. Is that correct?
Yeah, that's what my multi-evaluate does. And
why
it's
multi-evaluate?
Because it's using the down values that it suggests that it's like replacement for evaluation. You wrap it with unevaluated.
I'm sorry.
And no, yeah, in this case it's correct. What the hell is this?
Whoa.
I just haven't found any rules. That's why it was an empty association.
Okay. Okay, so it has a different behavior. Wow.
Oh man.
That's pretty elaborate. What is that?
You can just.
I'm just going to delete this. Okay, so but the point is that rules evaluate, or whatever it's going to be, but multi-evaluate seems like completely the wrong name because it's the multi-brand, but it isn't doing anything multi. There's nothing multi about it. But okay.
Oh, there's a multi about it because those down values. It's not like the first one that can be fired in the usual evaluator sense, but it can be applied in multiple ways in the same position, and apply and replace list. You know, there's all those multiness.
Okay, fair enough. Does not use downcode by default and does not and only, well, okay. I mean, it doesn't leave the fixed point thing. If nothing, okay, so this, okay, so what you're saying is, I think it has completely the wrong name because I was completely confused about what it does. I mean, what this is doing is it's giving you the evaluation data from a multi-evaluation. Is that right? That is
Right.
all of the, right?
Well, it's like almost documented page. You can look it up.
Okay, let's take a look.
Maybe it's a little bit confusing.
By a little bit, we mean, okay, that makes it. Okay. So this is what, okay, so this is using, we've defined patterns, and this is using, I mean, again, this is one of the confusing things, is there's so many different things you might want to do, like making this tree. Does that doesn't merge? So I see, so this one merges.
Yeah.
Okay, so for example, here, if I define my favorite Fibonacci here, so what would I do? I would define Fibonacci of n goes to Fibonacci of n minus 1 plus Fibonacci of n minus 2, and then I would define fib of 0 equals fib 1 is 1, and now I would say oh gosh, what the heck is that? Well, you don't say that. That looks right. Now let's do fib of 2. I don't understand this.
That's correct. It's applying rules without evaluating anything of its arguments, just as a replacement.
Okay, fine. So, okay, it's applying one-step rules. See, the thing that's super confusing is that in the system by default, this notion of an evaluator that takes only user rules and doesn't take anything else is absolutely not something we've never seen before, except in replace itself, if I'm making sense. That's what I think is really confusing, and I think it's probably a mistake. I mean, I think that for the time being, it makes more sense to support this kind of thing without trying to get any of this kind of, automatic sort of eating of things, I think. Because I think this we can understand what it's doing. As soon as it's doing this auto eating, everything's out of control.
Well, I think the whole point of the auto eating is like, this thing you have here is fine for combinators, but it's not at all, it's not useful for, for programming.
All right.
Like
okay.
if you want to write an actual program, you need to have the eating.
All right, so let's understand how this works. All right, so we've more or less got what's happening in the combinator case. And in this case, what we're saying is
right. So I think the way to think about it is the multi-object represents like, a non-deterministic, you can think of it as just representing like a non-deterministic program, right? And so if you apply something to the outside of it, you're going to get another sort of non-deterministic program, which is why it eats things.
Program, or is it a non-deterministic expression?
Expression. I mean, or
Right.
I'm not sure what the difference
Well, it's
exactly
a smart
is,
expression because it contains all the metadata about how to evaluate itself. So maybe it's like a program.
Right, but I think, right, I think in terms of design,
expression, but it's also a lazy non-deterministic expression in the sense that it didn't actually evaluate itself.
yes.
Yep.
But there is a function that you could imagine that just says, give me the fixed point multi from a given thing.
Well, it has all these different methods, right? So that would presumably be just one of the methods.
Yeah.
Right. Do you have that?
Fixed point, not yet, but it's having a graph and it's very close.
Okay.
Just a matter of actually doing it. Yeah.
Okay. So if is a lazy non-deterministic expression, and then, example of an operation, evaluate to a fixed point. And of course, it might not have a fixed point, and it might have 3 fixed points, and so on. But that's one type of thing you can do, is evaluate to a fixed point. Right?
So out of curiosity, I mean, just to see what it's like to write an actual program with this, that's not like a super, patterny thing. Can you try just writing something like try writing a select of range of 10, and then for the selector, just do multi of even q comma odd q or something like that.
Select range of 10,
and then multi even q odd q in a list. Right.
Yeah, that's interesting.
Okay, so now what do I do here? So I want to get evaluate
list.
Yeah.
Cool. That's very cool.
That is cool.
And you can see, because of the way, because we constructed the multi in a, in this way, it can also tell that it has 2 values, right? And maybe you could do something also like the range, maybe make the range multi of 10 comma.
Yeah.
Let's try it.
Maybe, make the multi there, right? And it should have 4 values now. Cool.
Let me look at the graph for this. So %384. So let's, what other things can we look at here? This
graph would be just only one step, I think. For the values case, it's always going to be like this. Maybe.
It would be a star graph. Or yeah.
Well, let me just see. The star graph with one. Okay, let me just see what the let's see, what is it called? Is it just graph?
Yeah.
Splatter.
Yeah. Well, maybe for the values, it's not really. I haven't tried graphs with values.
Okay.
Maybe another thing to try, just because this is the thing I was trying to figure out earlier, is what happens if you do instead of multi of 10 comma 15, if you do multi of, say, range of 5. Right. So the point is that the range is going to evaluate to a list.
Yeah,
and that going to possibly work. Yes, it does. Amazing.
Well, that was really the original motivation for doing something like this, and then to support down values and graphs.
Yeah,
and all the rules.
I do still think, though, that there should be some outer wrapper that even if it is just equivalent to unevaluated, there should be some outer wrapper that's like the the holding pen.
I think this thing, multi itself, I think, maybe I'm wrong, I think it should just not evaluate here. And that what should happen is that this is, there should be a multi-evaluate to whatever, multi-evaluate X that takes this expression, and that otherwise you can just put multis in and manipulate and do meta programming with multis to your heart's content, because they're absolutely inert, and only make it do something when you put the whole thing inside a multi-evaluate.
Well, but I'm not sure what you mean by absolutely inert, because if you say select of range of multi of whatever, the select is going to try and run.
I know, but as a
hold attribute, or presumably this needs a hold attribute, or you need to give the argument unevaluated.
Well, no, the multi-evaluate XX absolutely needs to be to hold its argument. But then what I'm suggesting is that the typical use case would be you build the thing with multis in it. I don't know.
But this doesn't make it any easier to do anything, though, because already, if you're in an environment where evaluation is being suppressed, then then the multi that eats everything you apply to it also won't be running.
Yeah. All right. Okay.
Right.
Okay.
So.
But okay, so let's just understand. Okay, so I want to look at the logic programming example, and then I want to think about examples where you are doing some kind of combinatorial searchy type thing. Like, is there a multi applied to a graph that walks through and generates all the paths in the graph? Is that a simple multi story?
It should be, right? Because it's just going to be it's just going to basically say, what's it called? Adjacency list of, the current vertex. It's going to say, and then multi of that, and then it's going to recurse, right?
So let's try it. Let's say
You need to do it with a DAG for that to work, I would think.
Well, or a loop.
Yeah.
Yeah, but well, this thing, you already tell it how many times to evaluate, right? So maybe it will, I don't know, maybe not.
Let's try it. Okay, so there's a graph.
Yeah, they're just two different graphs. Both are defined.
What? I was just going to say, go ahead.
For the DAG case, and also where you just have adjacency list and you might loop.
Yeah, right. Let's do the might loop case, okay? Of adjacency list. Let's call this okay, so GGR of hash. And then we want to say, what do we want to do here? We want to say nest list, maybe. This thing, comma, what do we want to do? We want to start with that. Is that right?
Well, maybe start with just no list around the one, just one. So think of the multi as random choice, right? If multi was random choice,
yes,
then it should, yeah, right. Then it should do one path.
Let's just try, just for my elucidate, let's try making this random choice.
Yeah.
That's very cool.
Perfect.
Okay. All right, so now let's go multi.
So is this multi-evaluator? This is, oh, whoops.
Yeah, that's tricky.
Well, hold on. So yeah, I know this is there's several things going on in this case, but when you do the multi-evaluator where you just give it a list and then you ask it to evaluate, is that using the normal evaluator though? Because in that case, it was calling down code, like when we had it calling select. And even queue and so on.
Well, if you just give it a list, yeah, it just evaluates the list. So.
But no, but sorry, I mean like I think maybe I was confused, but I thought earlier you were saying, when we had the combinators example above, that if you just said multi and then you gave it an expression on the inside, that expression, it would sort of take it apart. It wouldn't evaluate the normal evaluator on it. It would use its own sort of special evaluator that only could see, down codes, own codes, or down values, up values. But if you have stuff outside of the multi, that stuff that's outside of the multi doesn't get evaluated with that special evaluator. It just goes to the normal evaluator.
No, it will make the similar thing. It just bubble itself up even from, it will still gonna bubble itself up, the multi from any expression.
Right. I mean,
if it's not a held argument, So I think in this case, it's tricky because you have to hold your argument for the multi, because probably it just explodes at each nesting step there. It's like somewhere inside of the definition of nest list. No, so this ampersand function should be something like hold all complete in order for it to work.
Sorry, say that again. Which has to be hold all complete?
That ampersand function, the argument to the nest list. Maybe.
Well, okay, but I'm not sure that will work either. But the concept here, Nick, do you believe that this concept, I mean, up to the issue of how this all works with the evaluation semantics, which I think is a mess, but you think this concept should work? That is, that what I should get out here is a sequence of multis where the multis represent essentially the geodesic balls in this graph. Is that correct?
Well, if you just want a sequence of multis, it's already confusing. Maybe because as soon as you have a list of multis, it's gonna make a list of a multi of lists.
Yeah, I mean, you want a single multi anyway. I mean, you want a multi that
All right,
basically
okay.
is a non-deterministic. Just as multi of 5, 6 is sort of a non-deterministic thing. It's either 5 or 6. This should produce a new multi that itself represents non-deterministically some path of length 5
Right.
starting at vertex
Right.
1.
So an example of something we need to, we need some kind of multi-union, because clearly we're going to get a multi here that we both have. Maybe you already have this. It's both got path counting and it's got a union mechanism.
Well,
Right?
isn't just multi of list and then give it 2 multis? That's should generate the union of the multis, right?
No, but I'm saying that if we do this, right, that's got 6 values, but I might want that to only have 3 values. So if I was doing some kind of,
Sure, yeah.
That's an equivalence thing in the multi-way graph that we might need.
Or another example would be if you imagine running length of the nest list multi, then it should just return a single value of 5, right? Because they're always going to be length 5.
Maybe, yes, maybe. But look, the more important thing is that as this thing non-deterministically trees itself out, we may very well want a situation where it's equivalencing things and where the multi-way graph, well, I mean, see what's happening here. I don't understand why this thing didn't combine a bunch of those values. Because in this graph, it is combining them. Well, okay, we might want, okay, sometimes we want the values combined. Sometimes with their multiplicity kept. Does that make sense? I mean, that's the kind of path counting versus not. Nick, you get what I'm saying?
Oh, sure. Well, it seems like just some post-step processing.
Yeah, I agree. Probably so, except that we might want that to happen on an ongoing basis during the computation to avoid the thing blowing up like crazy. Right?
I'm not sure how you would do it in general, but yeah, we can make some option that
what do you mean?
for post-processing.
No, if the things are the same, right? If it's generating, I mean, it's like in this case, there's mergers in this graph, but the semantics of multi does not account for that merging until it is extracted in a graph. See what I'm saying?
No, it's like you're running multi-generationally. So you run your multi once, you get a list of results. If you have duplicates, just remove all the duplicates.
It does that automatically. Does it do that?
I'm not sure whether no, I'm not sure you should do it automatically.
Right, but okay, but what I'm saying is that so you need some mechanism, multi-union, something like that. You need something within the multi that tells it at every step, if you generate duplicates, get rid of the duplicates.
Yeah,
it's like a state equivalence function. Yeah,
it's some just option additional that specifies what post-processing steps you want to perform.
Fine. I mean, it's like a deduplication, like a token deduplication or some such other thing.
Sure, yeah.
Okay, but now, okay, so let's take a look maybe at your logic programming. Well, let's see, let's look at the multi-way Turing machine first. What the heck?
It's essentially the same example, just a different rule.
Well, what's this weird thing here? I don't understand what this weird thing is.
It's a rule that just using built-in Turing machine evaluation. It's not fancy, just a rule. It's not a rewriting rule as for combinators.
It's just saying that this is a single step and this is combining. This is saying for a given step, So this says, what do we apply the rules to?
Multi.
No. Forget the multi for a second. I just want to see a single rule application. It's this, right? If we say rules of that. No, rules, I'm completely confused here.
Just replace.
Replace.
Replace with these rules.
What is that?
I think it's just the first rule. If you want all of them to be replaced list.
Okay, but what are these? These are states of the Turing machine, the position, the head state, etc.
Yeah,
Is this like what
first...
the Turing machine function does?
Yeah, that's what it accepts there.
Okay, fine. Okay, so this is a one step in the evolution of a Turing machine. I'm pretty sure, by the way, that you can just say Turing machine of that it has a an operative form Turing machine, just for what it's worth. You don't need to say state, comma 1. Pretty sure if you say Turing machine 1337.
Just feed it a rule.
No, but I'm saying no. I feed it not a rule. I'm feeding it a
well, the number. Yeah.
No, there's its rule, but now I'm just saying that I think you can give it really. Oh, come on. Show me an example. Oh, for God's sake. There's an operative form that corresponds to one step of evolution. Why there's no example of that, I have no idea. Okay, fine. So rules.
Often, at least with cellular automata, the one-step evaluation things also return a bunch of like information about the padding and stuff like that of the
yes.
Yeah.
Okay, but anyway, so this is now the same kind of thing. This is make a multi-way graph for a multi-way Turing machine. Great.
Yeah, this is the example a little bit different just because you actually want your right-hand side to evaluate. And if you try it with some hold properties, which I didn't show for some reason, that would like...
Yeah, I know. This is a mess. I'm telling you, this thing with evaluation is a mess. I really think that the right way to do this... Look, I admit I don't really know, because these things are very nice. If we can make this really work. But we also want the case for these other more symbolic things where we don't want auto-evaluation, but we just want to use the rules I'm giving you and don't have all kinds of crazy encrustment to prevent evaluation. So
but the cool thing is if you can write a little bit of code like with rules, and then you can wrap stuff around it on the outside and have that work too, right?
Right.
Yes,
yeah.
I agree. Okay, let's look at this logic programming example.
It's like basically the first example from the Wikipedia page. I haven't really put much thought to it, but
okay.
The only thing that it's weird, and I don't know how to do it, you have to specify this last rule explicitly when the things are false. Because in prolog, for example, you just all the rules that you don't specify are assumed false, right? If you have a pattern that doesn't match anything, it's kind of false already. And I'm not sure how you do it explicitly, what exactly you should do.
Okay, let me understand this example. So in general, I'm so confused here. This is an expression and this is a rule. What the heck's happening here? Oh, no, I'm sorry. Can fly is this, so everything is a rule.
Yeah.
Correct?
Right.
And so what we're asking is, Okay, we want a series of rule applications. But isn't the point, like in Prolog, is you ask for something here and you want to derive,
Right.
you know, you want
That also kind of supported a little bit, because now instead of substitution, by default is by substitution. So so this X was actually binded to something. So it should be some kind of edge tag for that. So like the first edge has a tag that has this information of X binding to something else. So you actually can trace the graph and see the solution to your question in logic programming, the solution for X in this case.
And why is this not a token event graph? Why are the transformations not? I mean, okay, you can think of it as an edge label, or you can think of it as some kind of bipartite thing.
Yeah, you can explode each edge into event. I don't think it's necessary here, but because we don't have rules. It's necessary when you have left-hand side containing more than one token. If you have just one token, it can be well represented by a graph itself with some edge tagging.
Sorry, I got spaced out for a second here. Could say that again? I'm sorry, I lost that.
About tokens?
No, I'm okay. Let's understand. Again, I thought like the n queens problem, which I'm not even sure I remember exactly what it is, but that's like a classic logic programming problem. I mean, I'd like to see one that isn't one of these syllogism-ish ones, that is more bulk than this. If I'm making sense. I mean, or
there's like difficult examples come later, but again, I can imagine that it's a state would be on the whole chessboard, right? And
yes,
just a list of positions. It's just the problem just had to be stated in this way.
actually,
but I guess
no.
Logic programming is just the same as rule programming. It's just a list of rules in any case.
To what extent could we do? Okay, so let's remember the Towers of Hanoi thing that we just did for the mathematics project. Could we do that with logic programming?
Well, it depends what you want there. It's like a solution for what?
Well, I'm saying, okay, let's try to solve one of these problems. So we've got here a, we've got some proof. Well, okay, in this case, we're saying get from this configuration to this configuration, for example. Am I making sense?
Sure.
And it should be the case that just with essentially multis, it should be easy to specify this, because the multi is just, you can put this disk either here or there.
Yeah.
Strangely, I was supposed to be, we were looking at this multi-way games thing, and that was actually the meeting that I am missing that I have missing right now. Because I'm thinking, wouldn't that be a good example of this? In other words, this is a straightforward, or the tic-tac-toe case or something like that. It's a straightforward thing where there are multiple outcomes, and we have a question, which is, can you get, the logic programming question is, can you get from here to there? How do you do that? Does that make sense?
Is it the logic programming question? I thought it's like more of a particular logic programming is like asking for a variable that satisfies you some of the constraints, not the actual path.
So, well, okay, but I think you can ask. I mean, they're different things you might want. You might want the path. Okay, what are the different things here? Because this is what we're trying to inventory, right? So one class of problems says there are multiple things that can happen at each step. How can we get from here to there? That's kind of like theorem proving, right? We could do that. The theorem proving is like a replace list at every step with some, axiom application.
Yeah. And I think logic programming is the same thing, but as soon as you find a path that you are looking for that leads to true, for example, what variables to what values your variables are assigned to.
Okay.
Maybe enumerate those if you can.
I wouldn't quite phrase it that way. Logic programming is more, so if theorem proving is pure path generation or path finding, logic programming is allows you to solve essentially partial versions of that same problem. So logic programming allows you in general to say, given this proof, what were the axioms? Or, given this theorem, given this theorem and this partially constructed proof path, what's the rest of the proof path look like? Things like that. That's really what gives the power of things like mini-Canron's evaluate command, is the ability to reconstruct partial proof paths and things.
Yeah.
So hold on. So is it the case? Because I mean, one of the things that is, is one of the design problems is right now, multi-way system has this giant fiesta of different kinds of options and things you can ask for. And one of the things we're trying to do is to make that, factor that a bit. So what you're saying is, let me try to understand. I mean, so in general, with just find replace path, which is sort of my favorite minimal function, you're saying, so Jonathan, you're saying that in standard theorem proving, you're trying to do a find replace path. You're saying in the logic programming case, can you compare that again to find replace path, what you're actually doing?
Yeah. So imagine the case where you have part of a path and part of the goal, and you want to reconstruct what's the rest of the goal and the rest, what possible other parts of the goal and parts of the path are consistent, things like that. So with something like alpha Canron, you can use that to do theorem exploration, because you can partially specify a proof and partially specify a theorem. And then just have it explore possible consistent things that fill in the gaps.
Well, so for example, it will be a case, let's say with combinators, you could say, does there exist an endpoint that is less than 20 combinators long? Or show me all the endpoints that are less than 20 combinators long. Unlike with theorem proving, where you say, I want to get to this particular endpoint, you're giving some constraint on endpoints and asking for all such things. Would that be an example?
Yeah, sure. And so I suppose that the logic, if find replace path is kind of the minimal theorem proving case, something like explore replace path or enumerate replace path would be the minimal logic programming case.
Well, or where you do find replace path, but where the endpoint of the path is a pattern.
Right. But that only captures some of it, right?
Okay, fair enough.
Because you'd want a version of find replace path that can take in a partially specified path as well, or a fully specified path. And
so you're saying find replace path could have, I mean, in which case find replace path usually.
Because look, okay, again, to make the comparison with symbolic mathematics, there are kind of two limit cases of logic programming. One is the theorem proving case, and one is the proof checking case, right?
Okay.
So the theorem proving case is pure path finding. The proof checking case is you're given a path. Let me check the endpoints. So you're given a proof, and let me check that it actually proved the theorem you claimed it did. And then logic programming allows you to do both of those endpoints, but also everything in between.
I'm still a little bit lost. I mean, you're saying if I've given the path, I know everything that's on the path. So why is there anything left to do?
What do you mean? If you're just given a sequence of symbolic transformations, the problem of determining that those symbolic transformations yields the result, yields a certain result, is the problem of proof checking.
Yes,
that's what proof function does in find equational proof.
Yes.
Right. So my point is that proof checking is the other kind of limit case. That's the case where, so theorem proving is the thing where you know everything about the goal and you know nothing about the path. Proof checking is where you know everything about the path and you know nothing about the goal.
I get it.
And then logic programming is everything intermediate.
Fair enough. Fair enough. But okay, let's come back. We unfortunately have to wrap fairly soon here, but let's come back to, okay, I still think we have not adequately factored what multi can do. I think this whole eating versus whatever isn't quite right yet. But the very interesting thing here is you're basically saying you can throw a multi into any computation. And okay, with respect to those evaluation graphs we were looking at last time, we can have the single way evaluation path, we can have an evaluation graph when there are multis inside, which will be some much more elaborate thing, which is also what you're getting from the graph property of the multi. But
right. If you had a multi like just in place of a vertex in a graph, it would just mean several versions of this graph.
Yes. Yes. But with the understanding that representationally, for example, this whole question about duplicate elements in a multi, representation, there may be things where it should auto reduce itself, so to speak. If that makes sense, right? Because you don't want to blow it up with a giant tree all the time. Right? I suspect the reason why these things were slow is because it's blowing up to a giant tree and only reducing it after the fact. Right?
Maybe. Well, it's generating all the edges. In any case, it's even when the graph deduplicating your vertices, you still want to see all the edges that were produced the same vertex.
Fair enough.
So there's no missing information here.
No, I understand, but I'm saying I understand this has all the paths in it, but I'm saying that I think, well, I don't know exactly what you're doing there, but somehow, I mean, this is where we get into the whole foliations question of what, I mean, there's also the foliation question of how, okay, in our evaluator, we don't have a foliations question. Well, we do. We just picked a particular foliation and then we iterate until we get to the fixed point. But for this multi-way stuff, it is going to be much more common for us to not want to iterate to a fixed point, not least because there may be many fixed points or no fixed, or it just doesn't go to a fixed point at all. So we need more detailed control there.
Yeah, like one of the ideas that I have not implemented yet, because when you have a generational graph like this, you're essentially iterating that multi-list evaluate property that you have on the left, for example, right? Mm-hmm. Each result from this property just results in a list of results. So in principle, we just can specify a path as just a list of integers, how to move in this list of lists.
Yes.
So you just ask for multi, give it a part, and it will just give you a result as a single path when you just turn arbitrary each time.
Well, you're saying that in a multi-way graph, you can think of it like a tree, where at every level you pick which branch to take. Is that right?
Yeah, but this is like a lazy tree.
Yes, I realize that.
It's not evaluated yet, but you give it a part and it knows how to turn each time. And if there is no enough turn, you raise an error or something. Or do something more clever.
Okay, we need to wrap up, but what's some, do we want to define some next steps here?
Well, yes.
Okay, so to me, there's a bunch of, I mean, there's some pretty heavy lifting design around this multi thing that has to be done, because it's not, I'd really like to see, I mean, it's great to see the combinator examples and so on, because those are somewhat sort of real examples. I'm still not confident. I mean, I don't know, we presumably can write a SAT solver easily with this. Can we not? It's just we just take an original expression. How do you write satisfiability?
It's probably going to be the world's worst SAT solver, but maybe.
Well, of course it will be, but I understand. But we can at least see in principle how it works.
I guess just for each variable, you want to just kind of non-deterministically pick true or false with multi, and then just
Exactly.
I guess, yeah. Well, I guess there needs to be some way of being like, a multi dead end, right? For that to work.
Look,
right, because that's you're going to generate this multi, and it's going to non-deterministically pick something, but many of those non-deterministic choices you want to sort of prune out because they're going to get returned.
We have something like
false.
this, and then we'd have and then what we would do is for every one of those variables. Oh gosh, how the heck do I do this?
Right.
How the heck do I do this? I want to replace every one of those variables by multi true false.
Why don't you just say p arrow multi, or replace all p arrow multi true false, q arrow multi
Because
true
the multi
false.
is going to eat the whole world.
That's what it's supposed to do.
Well, it's a rule delayed, then it's fine. I think it should.
Okay. So p arrow.
I feel like it's supposed to eat the world, though. I mean, that's I don't know what else you would expect.
Okay, now what do I do?
Wait, why did those multis not? Oh, because is hold all.
Really?
Yes, because it needs to be able to short circuit. Like if you give it true, it doesn't evaluate the subsequent arguments.
Oh yeah.
Okay, so but in principle, this would, you see, what's interesting about this is if you think about the observer on this, the satisfiability observer simply has to ask, is there any true in here? It's a slightly different case than we've seen in other places. As opposed to the theorem prover, which says, is there any it was a little bit like the okay. All right, I think we should wrap up for now. LB on a large mass, is it helpful to think of multi as a general purpose vectorizing container? I'm not sure in the end, hopefully in a future world, perhaps we have the possibility to implement this somehow in the compiler with all kinds of different stuff. Okay. All right, let's wrap this up then. All right, well, to be continued. Lots of interesting things going on here. Unless anybody has one last comment. Anything else? Nope. Okay. Until the next time.